Alright, it's time to start with section number 5, which is essentially work and energy. And it's very important to have a pretty clear definition of work. For example, work, let me give you the exact definition, is the, let's say, the work done by a constant force, so we're talking about force, of magnitude F, of course it must have a magnitude, on a point that moves at displacement, and this is very important, displacement and not distance, S, in the direction of the force is the product. Mainly that force times that displacement will give you the work done on that object. So for example, you are here and you need to move this. You apply a force here, but actually, as the definition says, is the constant force on that distance, so it will be actually this. You need to break the force into x and y. The y vector will not help you, so we don't need that for our definition of work. And even though you are, I don't know, maybe you're using 100 newtons in that distance, you're probably just using 90 newtons in this actual distance, parallel to that of the displacement. So be sure always to be parallel to the displacement. Main units are Joule, or a little bit non-used because it's also for torque, it's Newton meter. So that's the definition of work. Probably you worked with that before, hopefully, because if it's not, I'm pretty ashamed that you haven't seen this before, because this is one of the most basic concepts on physics. Now, it's time to start understanding energy. This is a preview of work and energy. We're going to give more formal definitions later, but to get and give you an idea, the ability to do work, it's called energy. So any type of stuff that give you the ability to do work, that will be energy. The interesting, the very, let's say, important here is that you cannot measure absolute energy. We will be always calculating changes of energy, whereas here we can actually calculate the work done. So even though you know, for example, here has energy 1, and you move it here, you use the work, and it will be energy 2, the change in energy will be the work. Hopefully you're getting that concept also, because we will be using that especially in the first law of thermodynamics. So don't worry, this is just an overview, but it's pretty awesome that you start getting the concepts, the idea of work and heat. For example, heat is also a type of energy. It's similar to work, there are mechanisms that transfer, and this is very important, transfer a given amount of energy. These are like transfer energies. The measurement or the unit of energy is also the joule, because it's based on the definition of energy is also based on work. You could use heat, but I don't know why they choose work, probably because it's more standard. And by definition, is the mechanical work of moving 1 meter against 1 force of Newton. So for example, work will be the change of energy, and that's why you will have the force of 1 Newton times 1 meter. Now probably you've seen before that there are different types of energies, and that's true. There are transit energies and content energies. We're going to see that later. And common, let's say, content energies are kinetic energy, which is a object moving, radiant energy, which is carried by light. You know that light has photons and all that energy. Then also electromagnetic radiation, which probably you've seen before. Those are like waves, and they carry energies. Then potential energy, which is stored by virtue of the position of an object in a force field, such as either gravitational, which will be the typical potential energy we calculate, such as, and potential energy is mass, gravity, and change in height. Electrical magnetical field, imagine having a magnet here, you know, this will move and that will be work or energy. And thermal energy, you know, we're going to speak a little bit more of that later. So I bring you this, the relationship between work. You know that this little stuff, this electromagnetics, they move, so therefore this is doing work, and by definition it's changing energy. Now, if this guy, let's say, drops the arrow, he will be changing potential energy to kinetic energy. And these here, guys, they are using some electricity. The electricity is, let's say, not burning, but it's incandesating, or it's superheating this tungsten material, and therefore it's liberating electrons and energy, and heat energy, of course, also. And this will give you light and heat. So probably you're starting to get what we are wanting to do. We want to relate energy with other type of energies. For example, work, for example, heat, kinetic energy, potential energy, etc. And since this is an overview, we're going to stop right now. Later, we're going to see, of course, the difference of energy versus work. Just a review. All work is energy, but not all energy is work. For example, heat is energy, but heat is not work. You need energy to do work. That's a basic concept. If you don't have energy, you will not be able to do work. And you could get energy by not doing work. For example, heat or potential or kinetic energies, etc. And I'm pretty sure that you are kind of pissed off because of these circular definitions. Either energy is referred to work and work is referred to energy, etc. But you will probably see later that this is not the case, and just to wait for the first law of thermodynamics. I really recommend you to wait until you get into this chapter. Don't start looking out, because you're going to get confused and you're going to mess all your head and you're going to confuse terms. So right now, just know that energy and work are related, and heat is a type of energy, and so on. And that's everything for this little review, guys. In this section number 6, we're going to see other types of energies. What's up, guys? It's me, Chemical Engineering Guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos, or if I should be changing something, or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. Thank you guys for the support and the love.